All right, in 8.3, we're going to be factoring, and we're going to factor binomials and four-termed equations. Now, any size polynomial can have a GCF, and that's going to be like the foundation of what we're going to use to factor binomials and the four terms. So you always want to check for a GCF first, always. That is your go-to step. Then some of these formulas I will give you will work, but you always want to check that first. So let's take a moment and just review that. Look at this first trinomial. Notice this equation has a degree of 3. Remember, the highest exponent is called the degree. And so I want to see what can I take out of each term. Well, they're all even, so I know I can take a 2, and then I think through, and that's probably the highest coefficient I can take out. So I'm going to take a 2. Then I look at the a's. Well, the smallest one they have in common is a, so I'll take that out. And then remember, when you factor, you're essentially dividing. So I'm going to put the leftovers in the parentheses. So if I take that 6 divided by 2, I get 3. A to the third, divide out an a, I have a squared. Minus 12 divided by 2 is 6. A squared divided by a is a. Plus 14 divided by 2 is my 7. A divided by a is 1, so that's it. So this was just a basic GCF that we've done before. But I want you to look at number 2. It's different, very different. Notice it's got some x times x plus 6 minus 8 times x plus 6. So what I want you to see, that this is a very different kind of GCF question, but I want you to see that they have x plus 6 in common. Do you see that? So in this way, we're going to take out that x plus 6 as our GCF. So it's going to look like this, x plus 6, and then what's left, my leftovers, are that x and this minus 8. And now it's two binomials. Look at that. This is the method we're going to use when we get to the four-termed equations in a little bit. But let's first look at what we do with binomials. All right, so when you look at polynomials, you need to know that they factor according to their size. So first we're going to look at binomials. Remember what binomials means? Two terms. Two terms. So here's a special type of binomial. It's a difference of squares. So we have to remember that difference means subtraction, right? And squares means something is a perfect square. Okay, that's what I'm talking about. It's a perfect square. Like 1 is a perfect square, 4 is a perfect square, 9, 16, 25, 36, on and on. Those are perfect squares. So when you have binomials that are perfect squares, you're going to always have a minus sign and the square root of a perfect square. So let me show you. The formula looks like this. So you have a number squared minus another number squared. So notice it's a difference. And when we factor it, what we're going to do is take the square root of that a, which was just a, and we're going to add and then take the square root of b, and you get b. Then I do a minus b. So if you foiled that, a times a gives you a squared, and then a times negative b would be negative ab, positive ab, then negative b squared. You would end up back here. This is what the difference of squares looks like. It's a really easy one to factor if you start to begin to recognize the pattern. So again, the things to look for are perfect squares here, and a minus sign in between. So let's try a few of these. Let's look at this, x squared minus 100. So here's a perfect square, here's a perfect square. So I'm going to do square root of x squared is x, square root of 100 is 10. X plus 10 times x minus 10. And that's it. They're really quick. There's not a lot of work to show because they just follow the pattern. Let's try the next one. So 16y squared minus 49. All right, so I look to see, is it a perfect square? Is 16 a perfect square? Yes. Is y squared perfect? Yes. 49 a perfect square? Can I take the square root? Yes. And there's a difference between them. So let's do this. Square root of 16 is 4. Square root of y squared is y. Square root of 49 is 7, so I'm going to put plus 7. Then I'm going to do the same thing over here, but I'm going to put a minus in there. And that's it. That's your difference of squares. Now, let's look at the next one here. It's a little different. It is This one is x to the 8th minus y to the 12th, z to the 14th. Okay, that's really weird, right? We only have variables. So I want you to make a little note here. This is different. So here's what you need to know when you're doing this with variables. Variables are just the letters, right? So for variables, the way you find the square root of a variable is to take the power and divide it by 2. All right, so as long as your powers are even numbers, you can do this as a perfect square. So 8 is even, 12 is even, 14 is even, so we're good. We can make this a perfect square, and there's a minus in between, so it's definitely a difference of squares. So I take this 8, divide it in half, I get 4. Put a plus sign, y, 12 divided by 2 is 6, 14 divided by 2 is 7. Then I do the other one, x to the 4th minus y to the 6th, z to the 7th. All right, it looks really weird, but it is a difference of squares as well. Let's try number 4. Number 4 says 25x squared minus 1. Now, 25 is definitely a perfect square, so is x squared. But don't forget that 1 is a perfect square, because 1 times 1 is 1. It is a perfect square, so it does meet the criteria for difference of squares. So this would be 5x plus 1, and then 5x minus 1. Now, there's a reason I always do the plus sign first, and I'll get to that here in a moment. But for now, just go with me here. Let's look at number 5. 9x squared minus 64x squared y to the 8th. Now this one's different because I can do a GCF first, and you always want to do GCF first. Remember? Always check for a greatest common factor. Okay? This one, I can take an x squared out of both terms. So let's do that first because it always makes life easier on us if we do. So if I factor out x squared, that leaves me with 9 minus 64y to the 8th. Then I can check. I have my difference. 9 is a perfect square, 64 is a perfect square, and y to the 8th is a perfect square. So now I have x squared, and the square root of 9 is 3, plus square root of 64 is 8. Cut that y to the 8th in half, so it's y to the 4th. And then I have 3 minus y to the 4th. All right, so that's a little different, but it worked out. Number 6. X to the 4th minus 81. All right. Again, even-powered are perfect square. Even-powered variables are perfect squares. And 81 is a perfect square, and there's a difference, so it works. So let's do this. We have x squared plus square root of 81 is 9. And then I have x squared minus 9. Now, don't miss this. Look, there's a difference of squares again. There's another one. Another difference of squares right there. So I can keep factoring, and I should keep factoring. Now the x squared plus 9 doesn't work because it's a plus sign. This one keeps on going. So x plus 3, x minus 3. Now it's completely factored. So this is why we always do the plus sign first, so that if I can keep on factoring, it just keeps on tacking on the back end of the equation. Now, so let's look and see at our other ones. This one is a difference, but an 8 and the y to the 4th are perfect squares, but the 3 isn't. So this doesn't keep on going. This one is not a perfect square, so I can't keep on factoring. If I go to number 3, this x to the 4th is a perfect square, y to the 6th is, but z to the 7th is not. It's an odd power, it doesn't work. Number 2, 4y, not squared, so it's not going to work. X, not squared, not going to work. All right, so it only works if both terms are perfect squares and there's a difference between them, just like the original. So now what happens when an equation has 4 terms? What do you do if it has 4 terms? So basically, we're going to do grouping. And what does that mean? Well, that means we're basically going to do GCF, greatest common factor, twice. All right, you're going to do it 2 times, and I'm going to show you how. All right, so let's look at this first equation. X squared minus 2x plus 5x. Let's leave these separated. I know they're like terms, but we don't want to add them together because we want to group them. So resist the temptation to combine like terms right here. What you want to do is take your first 2 terms and your last 2 terms and group them that way. And you want to look at GCF between these first two terms. Well, x squared and 2x, well, I can take an x out, right? And then I'll have x minus 2. And I want to take that sign in the middle and copy it straight down. And then look at your 5x minus 10. What's the GCF here? It's a 5. And then I factor it out, I have x minus 2. Now I want you to look at what do these two guys have in common. Well, these two guys have the x minus 2 in common, don't they? So that's going to be what I'm taking out as my GCF. So I'm going to take out x minus 2. When I take those out, what's left over in the second binomial now is going to be x plus 5. There it is. It's factored out. Let's try the second one. Same idea. Group the front 2 and the back 2. Okay, look at the first 2 terms. What do they have in common? An x. So I'll have 4x left over plus 7. Now I'm going to take that negative sign and bring it straight down. And I look at my back 2 numbers. What can I factor out of both of those? Well, I can factor a 7 out. When I do that, now to be careful, I have negative 28 divided by negative 7 leaves me with a positive 4x. Negative 49 divided by negative 7 gives me positive 7. So be careful with your signs if you have a negative in the middle. You got to be real aware of that. Now notice, what do we have in common here, guys? We have 4x plus 7, right? That's our GCF. That's what we're taking out this time. So I have 4x plus 7. What's left over is the other factor. So the x minus 7 is my other factor. All right, there it is. Let's try one more. All right, group my first 2 terms. Or what do they have in common? Well, they have an a squared in common. Divide that out. I get ab plus a squared divided by a squared is 1. Bring that plus sign straight down. And then the back 2, what do they have in common? Well, they have a b squared in common. Well, if I factor that out, I have ab plus 1. So then notice what our GCF is going to be. It's going to be the ab plus 1. And what's left over is my other factor. So a squared plus b squared. Okay, now it's tempted to think that this might be a difference of squares because you have 2 perfect squares. But here's the catch. This is a plus sign. It doesn't work. It's not a difference of squares. It's the addition of 2 squares. So you can't just keep factoring if there's a plus sign. So this is where we stop for today. So hopefully that makes some sense to you, and let me know what questions you have.